P-value actually is a pretty difficult concept, but when you start doing homework, you will get a better feel or understanding of a p-value. What's the bottom line? What's the point of having a p-value? A p-value tells us how extreme or rare your sample mean is. So this is the definition of a p-value. Assuming that the assumption is true, what's the probability of observing a sample mean as extreme or more extreme as the one that you are having? Extreme can mean as small as or as large as. So assuming that the null hypothesis is true, what's the probability that you will get a sample mean as small as or as large as the one that you are getting? So this is the definition of the p-value. After you find your p-value, you have to compare your p-value with alpha. Alpha is kind of some sort of predetermined standard. So we call this alpha. It's pronounced as alpha. It's a Greek letter. So p-value, remember p-value is just a probability number. It tells you how rare your sample mean is. But how rare is rare? It's pretty subjective, right? So you have to have some kind of standard to benchmark your p-value against. So typically, people set alpha as 5% or sometimes 1%, so on and so forth. It depends on the researcher. But you need to set it or define it before you go and collect data. So you need to set what your standard is before you collect data. Otherwise, it will be some sort of cheating, right? So now alpha, the technical term for alpha is level of significance. What's the point of alpha? Alpha tells you how rare your sample mean have to be in order to be considered good evidence. So you compare p with alpha. If p is smaller than alpha, smaller than or equal to alpha, that means your sample mean is rare enough. That means you have enough evidence to say that the null is not true. So we say we reject the null. And your data are significant at level alpha. So for example, let's say alpha is 5%. Now you have a choice as a researcher to set what alpha is. Let's say your p-value is 2%. So 2 is smaller than 5. In that case, you make your conclusion as you say that we can reject the assumption. Now, so recall that we have two hypotheses. So let's use our example again. So mu is 4. Mu is bigger than 4. So when p is smaller than alpha, you reject the null. You're saying that the null is not true anymore. So you take the alternative hypothesis. So you say data are significant. In this case, you have enough evidence against the null. So enough evidence against the null, that means you're saying that the alternative is true. Now another scenario is if p is bigger than alpha. Let's say your p-value is 6% and alpha is 5% and 6 bigger than 5. In this case, your sample mean is not rare enough because it's bigger than alpha. So we do not reject the null. Data not significant. That means that, again, let's say if we have these two statements, when you say we do not reject, that means, when we say we do not reject the null, that means you are keeping the null. You cannot throw this away. You cannot throw the assumption away. You have to keep it. In that case, you don't have enough evidence to say the researcher's belief is correct. So the two cases, bigger than alpha, p bigger than alpha, or p smaller than alpha.